In this lesson, we're going to be talking about different kinds of transformations. Specifically, we're going to be talking about translations in this lesson. There are 3 different lessons that your notes, you have 3 pages of notes, and we're going to cover one each day this week. Translations are going to be the first one that we're going to cover, but our objective is going to be to find translations and to identify isometries. And we will define what an isometry is in this lesson as well. So the first definition is a transformation. A transformation of a geometric figure is a change in the position, shape, or size of a figure. In a transformation, the original figure is called the preimage, and the resulting image after the transformation is called the image. An isometry is a transformation in which the preimage and the image are congruent. Now, all 3 of these types of transformations that we're talking about in these lessons, they are all going to be isometries. The figure after the transformation is going to be congruent to the figure before the transformation. This is also, in some problems, it's also called rigid motion, because the figure is congruent to the original after the movement, after it's translated or rotated or reflected. The next definition is a composition of transformations. And that's just a combination of 2 or more transformations. It could be a translation followed by a reflection, or a reflection followed by a rotation. The only thing that's important to note there is that when you do have a composition, you have to perform each transformation on the image of the preceding transformation. So you just do one transformation, complete it before you do the second one that follows it. Next, we're going to talk about the notation that's going to be used. A transformation maps a figure onto its image and may be described with an arrow notation. So anytime you see an arrow notation, you basically read it as maps onto, and we'll see that in some of the problems below. Another notation that will be used is called the prime notation that you need to know how to read. It's sometimes used to identify image points. Here, K prime is the image of point K in this figure below. J prime is the image of J. And Q prime is the image of point Q. Now, the way we read this is that triangle JKQ maps onto triangle J prime, K prime, Q prime. It's also important to note that corresponding points of the preimage and the image have to be listed in the same order. So since this one was named, the preimage was named JKQ, the image had to be J prime, K prime, Q prime. The specific transformation that we're going to be learning about today is called a transformation. A translation is the type of translation. The more common name for that is a slide. But if you ever have to do this in, say, a constructed response assessment, they would want you to use the formal name for that, which is a translation. And it's just a transformation that maps all points of a figure the same distance and in the same direction. It doesn't turn it in any way. It doesn't change the size of it, which is the next blank we have, is that a translation is an isometry. So after it's translated, or after it slides, all of the sides, the corresponding sides are congruent and the corresponding angles are congruent. Let's look at the problems on the right side of your page. Problem 1 is identifying an isometry. The question is, does the transformation below appear to be an isometry, and explain. So let's think again about what an isometry is. The image, it started as the pre-image, and after it's transformed, it becomes the image file. And does the image figure, does that look like it's congruent to the first figure, the pre-image? So you look at corresponding sides, do they look congruent? You look at corresponding angles, do they appear to be congruent? And so the answer is yes, they appear to be congruent. In problem 2, we're going to be naming images and corresponding parts. In the diagram, it indicates that A prime, B prime, C prime is an image of ABC. So look at the images, and the first question says, what are the images of angle A and angle B? So you just look at corresponding angles. Angle A is going to correspond to or map to angle A prime, and angle B is going to map to angle B prime. In the second question, it says, what are the pairs of corresponding sides? So let's look at the corresponding sides. Side AB is going to correspond to side A prime, B prime. So if they correspond, they're going to be congruent. So let's look at that and label that as AB segment is congruent to segment A prime, B prime. Work our way around. BC, segment BC is going to be congruent to segment B prime, C prime, and segment AC is going to be congruent to segment A prime, C prime. Problem 3, we're finding the image of a translation. What are the vertices of the image of triangle RST for the translation x comma y maps onto x minus 3 comma y plus 4? And then we're going to graph the image. So to do this one, let's start by finding the coordinates of the points of the image, the pre-image that's here. So point R coordinate is 1 comma 2. Point S is 4 comma 1. And point T is 2 comma negative 3. So let's apply the translation formula to each one of these separately. For point R, R is going to map onto R prime. Let's calculate R prime using the translation formula. So in the point R, x is 1. And in the translation formula, we take whatever x is and subtract 3 from it. So 1 minus 3 is negative 2. In point R, the y coordinate is 2. So plug the 2 into the translation formula, which is y plus 4. And 2 plus 4 is 6. Do the same thing with point S. S prime, the x value is 4 for point S. The translation, whatever x is, you subtract 3 from it. So 4 minus 3 is going to be 1. And the y coordinate of S is 1. And we need to take y plus 4 for the translation. So 1 plus 4 is 5. Translate point t to t prime. The x-coordinate of t is 2. Substitute that into the translation formula. 2 minus 3 is a negative 1. Do the same thing with your y-coordinate, negative 3. Substitute it into the translation formula for y. Y plus 4, negative 3 plus 4 is going to be a positive 1. Now graph and plot each of these points for r prime, s prime, and t prime. R prime is negative 2, 6. S prime is 1, 5. And t prime is negative 1, 1. Be careful to note that the scale on this graph is going by 2s. Connect the points to make it the vertices of the triangle. And there is our resulting image. So we have translated triangle RST maps onto triangle R prime, S prime, T prime. In problem number 4, we're going to be writing a rule for a translation. So it's kind of the reverse from what we just did. We have the two figures, okay? The one on the left is the pre-image, your original, because it does not have the prime notation on it. So we have LMN is the original. LMN maps onto L prime, M prime, N prime. We want to know the translation rule for that. So we'll just take X comma Y, maps onto, and we need to fill in the translation rule that maps one figure onto the other. So just take two of the points that correlate to each other. So like M, for instance, if I take point M, then let's look at the coordinate for it. It's going to be a negative 2, comma, negative 3. And where it's going to translate to is M prime. So M prime here is going to be at, what is that, 4, comma 0. So the question is, how many units do you have to move horizontally to get M over to where M prime is? You have to move 2, 4, 6 units to the right. So that means you're going to take whatever the X value is, and you're going to add 6, because we moved 6 units to the right to get from M over to where M prime is. And then from that point, let's look at the vertical movement. The vertical movement, how many units do you have to move up to get from M to M prime? You have to move up 3 units. So you take your Y value and add 3 to get from M to M prime. You can check your other points. You can check L to L prime and N to N prime, and just double check your translation rule to see that that works for all of your points. In the last problem, problem 5 is about composition of translations. It says Carmen leaves her apartment and travels 2 blocks east and 5 blocks north to the library. Then she travels 4 blocks west and 1 block south to the grocery store. Where is Carmen in relation to her apartment? So you might want to think about this in terms of a compass, where your east and west are your horizontal movement, and north and south are your vertical movements. Okay? So let's just start with, let's say if she's at the origin, for instance, her apartment, and she goes 2 blocks east, then she's moved 2 to the right, which is a positive 2 movement. For your x coordinate, for example, would be your positive movement would be x plus 2. And then she travels 5 blocks north to the library. So she would go up 5 units, which is a positive 5 movement. The next thing she does is she travels 4 blocks west. So west is going to be a negative. It's to the left from where she is. So going west would be -4. And then when she goes 1 block south, she goes down 1 unit. That's going to be a -1 unit on your y, your vertical movement. So the composition of those two functions, if you look at that, you had a positive 2 movement on your x. So your net movement is going to be a -2. And then your y movement, your vertical movement, is +5, a +5, and a -1 is a +4. So where is she from her apartment? She is going to be 2 blocks west from it, and she's going to be 4 blocks north of her apartment after the composition of the translations.